Welcome back to the session of field theory. In this session, I will be discussing about most important questions and answers from module 2 of electromagnetic waves. So we'll be discussing individually. The first important question which I observed from the previous year university question papers is number one, state Poisson's and Laplace equations. You need to elaborate it. So explain Poisson's and Laplace equations. So you should have a good idea about the equation. So del square V is equal to minus rho naught 0 divided by epsilon. So you have to talk about like conditions also you have to specify. Rho V not equal to 0. Then regarding the Laplace, with respect to Laplace equation, del square V is equal to 0. So it is actually mainly used for like a charge-free region. So you have to talk about like a Poisson's equation and Laplace equation in details. If you want, you can add few more equations and slight derivation also can be added. Okay. So this is one of the important questions which I observed from the previous year questions. Another one is actually uniqueness theorem. You need to talk about the what is uniqueness theorem. So importance of uniqueness theorem you have to explain. Also why uniqueness theorem is needed for the context. Theorem states that the solution to the Laplace or Poisson's equation, which you already discussed, is unique if the boundary conditions are specified. That is actually called uniqueness theorem. Moreover, once the potential is found satisfying boundary conditions, no other solution will be existing. So that is another criteria of uniqueness theorem. So this condition also you have to explain. Okay. Possible, explain the mathematical equations. That is also one of the plus point. Then explain the Biot-Savart law. So why Biot-Savart law is required? You have to calculate the magnetic field due to small current element. So there is one standard equation. So explain the standard equation and elaborate the terminology. Sometimes you may have to derive, depends on the marks. If it is 10 marks, you need to elaborate it for like derivations. That is also expected. Other one, what is magnetic flux and magnetic flux density? So it may like directly short answers. Explain magnetic flux density. Even problem also we require. So we are to talk about the magnetic flux phi. Phi is equal to integral of B into dA. Okay. Where phi is the flux, B is the magnetic flux density, and dA is the very small element. And the magnetic flux density, magnetic field strength B. B is equal to mu H. Okay, B is equal to mu H, where mu is the permeability. So you can write mu is equal to mu 0 into mu R. Okay. Relative and absolute permeability. Mu 0 is the absolute permeability, mu R is the relative permeability. Also, like B is nothing but the total flux by unit area. It is expressed in terms of Tesla or Weber per meter square. So that also you can explain. Okay. Also, it will be helpful for solving the numerical example. That is also one of the noticeable point. Other one is actually 10 marks question. Derive Poisson's and Laplace equation from the Gauss law. It is very, very important. I have seen so many university question papers. Regardless of different university, not only VTU, other exams also I have seen that. So you have to follow the steps. Del dot D is equal to rho V. Then use D can be written as epsilon into field strength E. Okay. So now what you can do is E again you can modify like minus del V. So by substituting here, so instead of delta you keep as it is. Instead of that D, you are going to replace the term. So it become like in this fashion. Ultimately, the result is equal to minus epsilon del square V. Then we can write rho V is equal to del square V. This is called Poisson's equations. Remember, this is Poisson's equation. Also, like if we put rho v is equal to 0, from the Poisson's equation, you can derive the Laplace equation. If rho v is equal to 0, this equation is known as Laplace equation. So please do understand, this is also very important and pretty simple. In textbooks, they have elaborated for a certain extent. If you want, you can use the content, else you can go for the textbook as well. Explain and prove the uniqueness theorem. I already discussed about what is the importance of uniqueness theorem and the critical statement for the uniqueness theorem. So you need to like prove that two solutions like V1 and V2 satisfy the Laplace equations and boundary conditions. Then V1, you have to calculate V1 minus V2, that should be 0. Okay. Hence, it is actually, if you calculate V1 minus V2, that is equal to 0, then your 80% of the job is done. Use energy minimization principle or contradiction to prove the uniqueness. So based upon the boundary condition, you can prove. So ultimately, V1 minus V2 tends to 0. You have to prove, right? So it may ask for 8 marks questions. Then solve the Laplace equations in the Cartesian coordinate for one dimension case. So starting from the condition del square v is equal to 0 for one dimension. So ultimately you should get like a d square v by dx square is equal to ax plus b. In this format you should get, where a and b are boundary conditions. So you have to elaborate it, but this is only the tips. For your exam point of view, you have to elaborate it. That is very important. So if you write only this much, you may get a very less score. But I advise everybody to elaborate it certain extent. State and explain the Biot-Savart law with applications. Okay, three applications you have to explain. Derive infinite condition one. Derive the field due to infinite straight wire. Derive the field due to circular loop at center. Then also include the vector form and solve the integrals needed. State first of all you have to state what is Biot-Savart law. You can calculate the magnetic flux density for a very small element. You can calculate state the equations. Later on you have to have the derivations that you are expected to do. Okay, applications of Biot-Savart law. Other important theorem is actually Ampere's circuited law. You know, this is a condition. Like a closed integral, S dot dl is equal to the total current enclosed. Okay, that is a statement. You have to write the theoretical statement as well. Later, for the infinite straight wire, you have to apply. So ultimately, you will be getting H into 2 pi r is equal to I, where H is equal to I by 2 pi r. That means B is equal to mu H. So this condition, so you might have seen that it's a closed integral only. Closed integral S dot dl is equal to total current enclosed. So write the statement in theoretical fashion also. Elaborate this statement. Then we'll be writing H into 2 pi r. 2 pi r is equal to total perimeter, right? 2 pi r. That is equal to total, that is equal to, because it's a for I is equal to we can write uh, I implies H is equal to 1 I by 2 pi r. This expression you have to reach. Okay. Please do elaborate it. Don't restrict only these points. Please do elaborate it. Then differentiate between scalar and vector magnetic potential. Scalar magnetic potential is used in the region with no current. We can write a magnetic field strength is equal to minus del Vm. Similarly, vector magnetic field always applicable B is equal to del cross A, del cross A. These are the two differences you have to mention. So del cross A is equal to 0, that is Coulomb gauge. So you have to differentiate between scalar and vector magnetic field by using these equations. Okay. So basically you can showcase this equation, but you are supposed to elaborate. There are few more important numerical examples you can expect in the university examination. Surely, you'll be having the options, but each option, definitely one numerical example is included. Solve the Laplace equation for the rectangular region with the given boundary conditions. What you're supposed to do is use separation of variable method or assume polynomial solutions. Other one is actually compute the magnetic field at a point due to a long straight wire using Biot-Savart law. It may be like a circular or a long straight wire. Yeah, it may be in the form of theoretical question also you can explain or you can expect it. Using the Biot-Savart law, find the magnetic field inside and outside the coaxial cable or hollow conductor. You are supposed to prepare any one of the shapes. Okay. Be ready about these questions. You can expect few more numerical examples. Okay. If you're watching our channel, I request you to subscribe so that you will be getting similar kind of videos in future. Also, I request you to like this video, give you a valuable suggestion for our improvement. And please don't forget to share with the stakeholders those who are preparing electromagnetic field theory or field theory for either EEE or EC or EAE students. Okay. So thanks for watching this video. I wish you all the very best for your examination. Please go through these questions before appearing for the university examination. So thank you all. Have a nice day. Happy learning.